Hello everyone, and welcome. Have you ever encountered a problem that seemed impossible to solve until you found a clever workaround? In the world of chemical analysis, scientists face this all the time, especially with a technique called gas chromatography, or GC. GC is fantastic for analyzing substances, but only if they can be turned into a gas easily. So, what do you do with molecules that refuse to cooperate? That's where a powerful chemical trick called derivatization comes into play, and today we're going to explore exactly what it is and why it's so crucial. In simple terms, gas chromatography separates compounds in a mixture by turning them into a gas and passing them through a long, thin tube called a column. Molecules that are volatile, meaning they have a low boiling point, travel through the column quickly. However, many important molecules, like sugars, amino acids, or certain drugs, are not volatile. They contain polar functional groups, like OH or NH2, which act like sticky hands, causing the molecules to cling to each other and to the column. This makes them difficult to vaporize and results in poor, broad peaks or no peaks at all. Derivatization is the solution. It is a chemical reaction performed on our sample before it's injected into the GC. We add a special chemical, a derivatizing agent, that modifies our target molecule, essentially giving it a new disguise to make it GC-friendly. There are 4 main goals for doing this. First, and most importantly, is to increase volatility. The derivatizing agent masks those sticky polar groups. For example, a common technique called silylating replaces the active hydrogen in an OH group with a non-polar trimethylsilyl group. This breaks the strong intermolecular forces, drastically lowering the boiling point and allowing the molecule to fly through the GC column. Second, derivatization improves thermal stability. The high temperatures inside a GC can break down fragile molecules. The new chemical group acts like a protective shield, preventing decomposition. Third, it can enhance detectability. Some derivatizing agents are specifically designed to make the molecule more visible to the GC's detector, allowing us to measure even trace amounts of a substance. Finally, all of this leads to improved chromatography. By making molecules more volatile and stable, they move through the column smoothly, resulting in sharp, symmetrical peaks, which are essential for accurate identification and quantification. In essence, derivatization is a preparatory step that transforms uncooperative molecules into ideal candidates for GC analysis, expanding the power of this technique to a much wider range of compounds. And that's a quick look into derivatization in GC. It's a fundamental technique that makes the impossible possible in the lab. Thank you so much for watching. If you found this video helpful and want to learn more about analytical chemistry, please consider liking this video and subscribing to support the channel. It really helps us create more content for you. See you in the next one.